Today I'm going to be talking about misconceptions in gravity. Such misconceptions are that in the Earth, people seem to think that the value of gravity does not change according to distance. So say if you're in the Earth's crust, on the surface, or all the way up in space, people seem to think that gravity does not change. Another common misconception is that if you're in space, all the way up here, some people seem to think that there is no gravity at all, and that you will just endlessly drift off into space. But today I'll be talking about the misconception in gravity that all objects will fall at the same rate. This is in fact true. So say if you have a small tennis ball and a bowling ball, they will both fall at the same rate of 9.8 meters per second. But who was the first man to put a label on gravity? It was Sir Isaac Newton. As the legend goes, an apple fell from a tree and landed on his head. This caused Sir Isaac Newton to ponder why the apple landed on his head. This probably went a little like this. Sir Isaac Newton's definition of gravity states that gravity is proportional to the mass of the object and the positioning from the center of mass, such as the Earth. An example of this can be seen on screen, as the Earth and the object are separated by a distance of r. The man to put the misconception of objects falling at different speeds to test was Galileo. He hypothesized that with the removal of a medium, such as air, objects would fall at the same speed. To prove his hypothesis, Galileo created the famous thought experiment involving the Leaning Tower of Pisa. He stated by dropping two objects of different weights, they would hit the ground at the same time, neglecting the medium they traveled through. To further prove his hypothesis, he used mathematical equations such as Kepler's law and the law of universal gravitation. An easy way to explain this is a simple equation of acceleration equals force divided by the mass. When two objects are involved, the two acceleration formulas equal each other and create the ratio, which is called the gravitational field strength, which on Earth will always be equal to 9.81 newtons per kilogram. Using this, we can see that a force of 9.8 newtons will be placed on any object, regardless of the weight, thus showing that objects will fall and accelerate with a constant speed of 9.81 meters per second squared. The medium falling objects travel through is known as air. When an object falls to the ground, it constantly runs into air particles. This continuous collision causes the object to slow down, as follows. This upward force is called air resistance. In order to explain air resistance, we must start to look at its equation and how to calculate air resistance. In order to debunk the misconception of objects falling at different speeds, we must look at what the letter A stands for. This letter A stands for the surface area. This shows as the bigger the surface area is, the higher the air resistance is. This results in the object falling slower. An example of this is a piece of paper and a pen.